Hey, I'm here with Benedikt in the IBM Zurich Research Lab, and today we want to talk about TerraTorch, what it is, and also how you can become a contributor. So Benedikt started as a TerraTorch user and later became a contributor, and therefore I think he's the best guy to actually describe all about TerraTorch. So could you maybe summarize what TerraTorch is in 2 to 3 sentences?
Sure, yeah, nice to be here. So TerraTorch is basically a fine-tuning toolkit for geospatial foundation models. So it includes a lot of different foundation models, and with Lightning AI, it makes it easy to fine-tune these models for a specific use case. So you basically just have to provide some data, configure something, and then you basically get like a fine-tuned model out of it.
Okay, so you provide data modules and modules for Lightning, basically. Is it what it is?
Yeah, basically. So you need like a data module which handles like all the data loading and so on. You can have that custom. So for example, you could use like all the data modules from TorchGeo, but we also have like some generic ones in TerraTorch, where you only have to have like the data in a right format, and then it basically can automatically be loaded for the fine-tuning.
Okay. How does it work with integrating new foundation models? Is that a simple task or is it complicated?
That's also quite simple. So that's, for example, how I got into developing more for TerraTorch. So I built a foundation model and we wanted to like make it available to everyone with TerraTorch. And that's quite easy. So like there are like 3-4 steps you have to follow. You don't really have to adjust a lot of code. It's just like the output of your model has to have like a specific format, like similar to, for example, a TIM library. And then you have to register it in the TerraTorch registry, and then everyone can use it if you publish it.
Okay, so it also supports like CLI only execution, where you have a YAML file with all the configuration parameters. So is it that simple that you just change the name of the foundation model and you can just run with a different foundation model, or is there something else to do?
That's the case most of the time. So we basically have like in TerraTorch like a very huge registry of a lot of different foundation models, but also like generic models from TIM and so on. And you basically have just to select the name of the model and tell TerraTorch to load the pre-trained weights. And that's kind of it. Of course, you sometimes have like some things you have to adapt based on the model. So for example, with TerraMind, with my model, you have to specify which modality you want to fine-tune, but that's basically one additional parameter in your CLI config.
Okay. So you added the capability of running multimodal models in TerraTorch. Was that a huge task?
That was actually quite a lot of work, but mainly because we added like a new generic data module for multimodal data. So now when you have multimodal data, like for example S1 and S2, you don't have to create like a custom data module, but like only have to have it like in different folders, kind of specify it in a config where the data is, and the data module does everything for you.
Okay, cool. Okay, so let's have a look at how you can start contributing. So I've opened the dashboard here of TerraTorch, and we have marked a lot of issues with Good First Issue, and you can just pick one and let us know. We have 2 weekly community calls happening at Tuesday and Thursday. It's all described on the TerraTorch GitHub page, which is github.com/ibm/TerraTorch. And now let's have actually look at some code. So I've now opened here a Colab notebook where we have an example, I think, which you created on the TerraTorch and TerraMind. So what I've done so far is I've selected the T4 runtime in Google Colab, and I've installed all the dependencies. And now it should ask me actually for a restart, which it doesn't. That's interesting, but I will do it anyway, just to be on the safe side, no?
That's a good idea, definitely.
So how do I restart?
On the runtime, I think. Restart session.
Okay. So it's restarting. Okay.
So this is an example where we basically use TerraMind with the Floods 11 dataset. So that's a quite nice demo dataset for predicting floods. And what we do is basically we first install, of course, TerraTorch into the runtime, We load the data. It's not too big. It's a couple of gigabytes. We have a look at the data and then finally fine-tune the model. So that's basically it. And if you want to adapt it, you kind of just have to specify like different paths and number of classes and so on. But the rest should basically work the same.
Okay. So let's have a look while this is running. What's happening now? First of all, you download the Zen 1 and Floods 11 dataset. That's what I'm getting from here now. And then this is a data module. No, this is a Lightning data module at the end. So what do you specify here? I think that sounds a little bit like this multimodal magic, no?
Exactly right. So this is, as you can see there, the generic multimodal data module. So what you do is basically you just define the different modalities you want to have in fine-tuning. So here, for example, S2L1C and S1GRD, and then you just provide the path where this data is stored. And then after that, we specify some split files. So these are text files which indicate like the sample file names. So that's what the data module uses to match the different samples between the different modalities. And that's kind of it. Then later you, for example, could also specify some dataset bands if you want to fine-tune only on a subset of the bands. But here, for example, we use the same. So that's something you could also leave away. And then, then some magic happens and basically the data is loaded.
Okay. So then we go here, I would say...
Yeah, maybe you can execute it so that we actually see some plots.
Let's see. That's fine. Okay, now let's execute everything and see how it goes. So it's not prepared, it's brand new and freshly cooked. So okay. Yeah, this is downloading here from Google Drive. So we have a copy of all the data on Google Drive because it's just way faster now when you run on the Colab environment. And let's give it a shot. Okay, this is done.
You want to remove maybe the output. Looks nicer.
I think so. Okay.
Like at least like make it smaller.
Okay. Good. Okay, so it's TIFF files I can see. So it's GeoTIFF, no? And now the data module already got instantiated. And here we see something. What do we see here?
Yeah. So as we saw, basically we download data. And run all the above cells, and now we can have a look at how the data looks like. So there, for example, we see some Sentinel-2 images. So that's a modality we use for visualizing it with the ground truth map, and that's basically what we use as data for training our model to predict water.
Okay. So
here, for example, we see all the different registries we have in TerraTorch. So basically TerraTorch is quite modular, so you can basically build your own model together with different parts. Specifically we have like backbones, which are like the foundation models. Then we have some decoders, and in between some necks you need to like make it work kind of, and in the end a head which actually generates the output. And for all of that, TerraTorch has like different registries. Here we look at the backbones. So for example, for TerraMind, we have like 4 different versions registered, and that's the ones you can basically select for fine-tuning as your backbone kind of. The decoders, we also have different decoders, like for example UNet or a linear decoder, which you can use for classification. Also UpperNet, which is like UNet, a multi, like a hierarchical decoder, which basically takes like multiple outputs from the model at intermediate steps.
Okay, and the next is basically just a transformation step, no, which you can hook into the model.
Exactly.
Okay, now you see here we have here checkpoint downloaded, 1.5 gigabyte, and this is already the model, no?
Exactly right. So that's basically if you want to use a model from TerraTorch in like your custom pipeline, you just need like a PyTorch model. That's how you would like instantiate a model of TerraTorch, and then you can use this backbone for whatever you want in your fine-tuning pipeline.
Okay, so what can we do with that model now?
So next we can basically use this model for training a model with PyTorch Lightning. For that we just use like a standard Lightning trainer, so that's what you highlighted here now. So where we can define different things, like for example if you want to use mixed precision and so on, or which callbacks we want to use. So here for example you use a callback for saving the actual model output, or like the fine-tuned model. And that's something you can just look up like the Lightning documentation, and you can modify it as you like. So for example it also automatically grabs your GPUs by specifying as auto.
Okay, can you maybe explain why do we have this task here and what the data type of this task is?
Yeah, so what Lightning expects as the model module is some PyTorch module which has like training, validation and test steps. So this is not an actual model, but that's how Lightning is calling a model. So a model has like these steps. What TorchGeo and also TerraTorch does is calling it them tasks. So a task is something which loads then the model and so on, and handles all these fine-tuning steps, like how does a training step look like, how does a test step look like, so on. And that's basically all in these tasks. And that's something you don't have to do, because you can just like use the default ones from TerraTorch, what we do here, for example, for the semantic segmentation. And within this task, we basically then have like this factory, which then builds this modular model where we then specify the model arguments. So that's where we actually define how our model should look like.
Awesome. Okay. Yeah, that was confusing to me that it was called task, no, and I never got it. So that's something you need to be aware of.
And for example, if you go back a bit, there we also see like these necks. So the idea of these necks is that not every output from a backbone works with every decoder. So for example, TerraMind is like a VIT model, which has like always the same output structure from every layer. But for example, the unit decoder expects like hierarchical inputs. So these don't match. Also like in a VIT, you have like a 1D token dimension, but the unit works on a 2D grid. So that's how we like have to like reshape the outputs of the encoder a bit, and that's what we're doing here. We are selecting like which layers we want to use, we reshape it to 2D, and we also have like some interpolation happening, which is learned to actually get like these hierarchical inputs for the decoder.
Okay, and the cool thing is the whole fine-tuning pipeline then is expressed without code, no? You can just have a config file with that idea of the next, no?
Exactly right. So that's here now a notebook, but you can specify exactly the same in like a YAML config.
Okay.
Yeah.
So this is the training one. It's currently running, it seems.
Exactly right. So then you just run trainer fit. So that's again like classic Lightning, where you pass like this TerraTorch task and the data module, and then Lightning handles all the rest. And here we specified like 5 epochs to have it a bit simpler, and we can actually have a look at this training. If you go back to the TensorBoard, by default basically everything is logged into TensorBoard, and if you like upload it or like update the site, we can actually see how the model trains. So that should be done. So if you go down a bit, you have for example training and validation steps, and then we can actually check how the training is working. Maybe make this moving out. Just to 0. Oder soll ich es vielleicht zeigen? Okay, ich wiederhole es einfach kurz. Okay, so now we basically see how the Lightning trainer is fitting the model. So you just pass the model and the data module, and Lightning handles the rest. And we specified here like 5 epochs just as a demo. We can see how the training is running. And we can check that actually in the tensor board. So if we update the tensor board, we can check the results. So for example, TerraTorch automatically logs the images so that we can actually check what the model is predicting. And we see, for example, here, the model is already working quite well on the validation data. So this maps quite okay for only like 4 or 5 epochs. And further down, we can basically check like the training loss here, and also like the validation loss, how this is performing. So this is basically based on the epoch, where we, for example, have like this is the MIU, which is increasing quite rapidly here. And that's how you can like monitor your training and like also analyze it later and compare different runs.
Awesome. Good. So, and I assume when this is done, we will see the outputs.
Exactly. So
this is
there
done. Okay.
Stopped after 5 epochs, and here we already run the testing, and there we actually see the test scores. So here we see, for example, that we have like an MIU of like 78%, but again, like only after 5 epochs. So this will be much higher if you run like a full fine tuning with like 100 or 200 epochs.
Okay. So this is looking interesting, huh?
Yeah, here we have some examples for predictions also on the test set. So we do see that the model after 5 epochs is not like super good, but for some example, it's already working quite well in detecting the data. So for example, in the second image, we see a lot of clouds, but I would assume that like the S1 data can actually look through the clouds, and maybe there's water under these clouds, which we can't see as humans.
Interesting, huh? Okay. By the way, you loaded one checkpoint. Okay, you maybe explain what this checkpoint was all about and why you are training?
Do you mean like the pre-training checkpoint or like the fine-tuning? Yeah, so basically like the checkpoint is like some collections of weights. So that's something we do in pre-training, where we have like terabytes of data and we train a foundation model, which basically learns to understand satellite data. And this is all saved in like some checkpoint, which you can see here, like this PT file. And this basically gives the model like a head start in fine tuning, because it already understands satellite data a bit better. And that's why it can like converge faster, generalize better, and also like in the end often gets like a better accuracy than if you would not use a pre-trained model.
Okay. So based on the checkpoints, this was the fine-tuning task, basically.
Exactly. Yeah.
Okay. Good. I think that's all. So if you want to start contributing, just have a look at the open issues. We also are always happy if you improve our documentation, or you just tell us if something is not working. And of course, you are free to join our weekly community calls. It's Tuesdays and Thursdays. And also we have a Slack channel, which you will find below. Thanks a lot. And thanks a lot, Benedikt, for helping out.
Sure. It was nice.
Okay. Bye.